Problem 10 of the MIT Integration B qualifying exam 2012, which is indefinite integral of x minus 1 over x plus 1 times the square root of x cubed plus x squared plus x. So this is also a very interesting problem. I hope you enjoy following along. This is our problem. X minus 1 over x plus 1 times the square root of x cubed plus x squared plus x. So as I always say, try to substitute off the most complicated part. But looking at these powers here, when differentiated, kind of complicate the expression I want to look at. So what I would do, I would divide across by x squared, and that means that this expression becomes x minus 1 over x plus 1. If I pull x out, you have x plus 1 plus 1 over x. And this is interesting. So let's try to substitute for that. Say let y be equal to the square root of x plus 1 plus 1 over x. That means that y squared is equal to x plus 1 plus 1 over x. And so what that also means is that 2y dy dx equals to 1 minus 1 over x squared, which is x squared minus 1 over x squared, which is the same as x minus 1, x plus 1 over x squared. So that's the bit that we've been able to do. So we've, in other words, gotten that 2y dy dx is equals to x plus 1, x minus 1 over x squared. And that means that we can use 2y dy to substitute off this part. So this is our problem. And so if we have x minus 1 over x plus 1, x square root of x plus 1 plus 1 x. This is the same as x plus 1 squared and then we have x plus 1 up x minus 1, and now we will put x here so that we have x squared here, and then we have x plus 1 plus 1 over x. So this is important because we want this part, actually this part here, that resembles what we have here. And then obviously this part is going to be y. So one other thing we can do is we can expand this guy out. So we have x plus 1, x minus 1, x squared plus 2x plus 1 is x squared times x plus 1 over x dy. So which leads us to say now that we have x plus 1, x minus 1, x squared plus x plus 1 plus. That's important, how I've written like that. So the next thing I would want to do, I can pull x out from this part here. So I have x plus 1, x minus 1, pull x out, I get x plus 1 over x. We've made a small errata there, so I need to delete this. And then plus 1 x squared so we can see that that and that cancels, and then this part here becomes 2y dy, and then this part is y, but this part here is now y squared, and there's a 1 remaining there. So we have the integral of 2y over one plus y squared times y, and that cancels, so we have 2 dy over 1 plus y squared integral. So that's interesting. We're getting there. So integral has become the integral of 1 over 1 plus y squared. If we say let y be equal to tan theta, then dy d theta is going to be equal to sec theta, dy is theta. So our integral here becomes 1 over 1 plus tan square theta, because this y, and then dy here becomes sec theta d theta. And since 1 plus tan square theta is a sec square theta, this and that would cancel. So now we have twice the integral of 1, which is twice theta plus the integration constant. So if our integration has become that, and since we also say that since y was said to be equal to tan theta, then that means that theta is equals to the arctangent of y. And that means that our integral becomes twice the arctangent of y plus c. But also, since we said plus 1, then our integral x minus 1 over x plus 1 square root of x cubed plus x squared plus x is equals to twice the arctangent of the square root of x plus 1 over x plus 1 plus the integration constant. And that is, ladies and gentlemen, our answer.